students. So in this video, we'll see MCQs on motion of charge in an electric field. So motion of charge in an electric field. So I will take two plates, or you can say this is a positive plate, positively charged, and another plate is negatively charged. So this I will take it as negatively charged. So electric field will be acting from positive to negative. So electric field will be in direction positive to negative. Consider initially a charge is placed inside this electric field. A plus Q charge is placed, or initially it is at rest. So when you place an when you place a charge in an electric field, so there will be motion, or it will move away from positive plate towards the negative, or you may say it will move in the direction of electric field. So now various formulas which we need to simplify. First, so the force acting on that charged particle. So force F is given by Q into E. F is equal to Q into E. So after certain time t, so after time t, so the charge will move, it will have an acceleration. So acceleration is given by Newton's second law, that is A is equal to F by M. F is Q into E divided by M. Third, its velocity after time t. So I will use V is equal to U plus AT. Therefore, V is equal to initial velocity is 0 as it is at rest. A is QE by M into T. So velocity after time T is given by QE by M into T. Rather than remembering the formulas, you remember the method how we get those formulas. So the distance traveled by charge in time t is given by S is equal to ut plus half at square. So initial velocity is 0, so this is 0. Half A is QE by M, QE by M into T square. So distance traveled S is given by QE T square by 2M. Distance traveled is given by QE by 2M into T square. Fifth, even you can apply this formula, that is V square minus U square is equal to 2AS. So where U is 0, 2, A is QE by M, and distance traveled here we are having. So if you substitute that, you will have V square. Sixth, after traveling certain distance or after time t, its kinetic energy is given by half mv square. So if I substitute half mv square, if I take, it will be q square e square t square divided by m square. V square is. So 1 m gets cancelled. You will have q square e square t square divided by m. This will give kinetic energy after time t. So based on these formulas, we will see few MCQs, that is motion of charge in an electric field. So if you want, you can take the screenshot or note on these formulas. Now first MCQ or first problem, an alpha particle of mass. So he has given mass of alpha particle and charge is situated in a uniform electric field he has given. You are required to find velocity of the particle at the end of. So he has given distance starting from rest means u is equal to 0. So here he has given yes, he has given he has given this is the distance traveled by the charged particle. Yes, he has given m, q, and electric field E. So yes, he has given you are required to find the velocity. So velocity in terms of S is given by formula v square minus u square is equal to 2as. So u is 0, so v square is equal to 2 qe by m into distance s. Now substitute all the values which he has given. So 2 into charge of alpha particle is 3.2 into 10 raised to minus 19 into electric field E is given as 1.6 into 10 raised to 5. Distance travelled is 2 into 10 raised to minus 2 whole divided by mass of the alpha particle. So mass of alpha particle is 6.4 into 10 raised to minus 27. So this is v square. Now simplify. So if I simplify 3.2 into 2 is 6.4. So this gets cancelled with 6.4. Now all the values try to keep it in perfect square. So v square is there 1.6 I will write it as 16 110 from 10 raised to 5 I will multiply to 1.6. So it becomes 16 2 into 10 raised to minus 19 as it is. This 5 becomes 4 because 110 I have multiplied to 1.6. 10 raised to minus 2. If I take this to the numerator, it will be 10 raised to 27. So I will have v square is equal to 16 into 2 into simplify the powers of 10. So minus 19 plus 4 means minus 15. Minus 15 minus 2 means minus 17. Minus 17 plus 27 means 10 raised to 10 you are having. Now take the square root. So if you take square root of 16 is 4, root 2 into this is 10 raised to 5 meter per second. So if you check the options, C is the answer. Clear, students? So we will move for next one. An electron initially at rest. So he says that initially it is at rest means U is equal to 0. So initially at rest he has given. So U is equal to 0. Falls a distance of 1.5 centimeter. You should convert it into meters. So yes, he has given. In a uniform electric field of magnitude E has given. You are required to find the time taken. E has given. So yes, he has given electron. He has told means you are knowing the mass and charge of electron. So time we are required to find. Yes, he has given means we will be using formula S is equal to ut plus half at square. So now if you substitute S is equal to U is 0, so half A is QE by M into T square. I am required to find T, so T square is equal to 2M into S. I have cross multiplied this to LHS divided by Q into E. Now substitute all the values and simplify, you will have the answer. So I will take T square is equal to 2 into mass of electron. So mass of electron is 9.1 into 10 raised to minus 31 kg minus 31 kg, 9.1 into 10 raised to minus 31. Distance traveled is 1.5, it is in centimeter, means into 10 raised to minus 2. Whole divided by Q into E. Q is charge of electron, 1.6 into 10 raised to minus 19. E is electric field to 10 raised to 4. Now simplify this. Now see here. If you go on multiplying and dividing accurately, you will not be able to finish the problem within 1 minute. So I will take approximation. So if I take approximation, this 2 gets cancelled with this 2. 1.6 and 1.5 get cancelled. 9.1 approximately I will take it as 9. So into what remains 10 raised to minus 31, 10 raised to minus 2, 10 raised to minus 19 if it comes to numerator plus, and 4 if it comes to numerator it becomes minus 4. So t square will be equal to approximately 9 into 10 raised to. So simplify. Minus 31 minus 2 is minus 33. Minus 33 minus 4 is minus 37. So minus 37 plus 19. So minus 37 plus 19. So if you simplify, so this will be equal to minus 18. So minus 18. So 10 raised to minus 18. So power is also even. So directly you can take a square root. So t is equal to 3 into 10 raised to minus 9 seconds. So 3 into 10 raised to minus 9 seconds. So if you see the options which is very near to 3, so option C will be our answer. That is 2.9 into 10 raised to minus 9. Clear, students? So just by taking approximation, we get the answer. Next, third one. An electron of mass Me. So first he has given electron. So there is an electron. Its mass is m. Initially at rest he says moves through a certain distance in an uniform electric field in time t1. So time is t1. A proton of mass mp. So proton mass is mp. Also initially at rest. So this is also at rest. Takes time t2 to move through an equal distance. So means in both case distance is the same. So S is the same in both. You are required to find the ratio of T2 by T1. In this uniform electric field, he says, means E is the same. E is the same. Then the charge of both proton and electron is the same magnitude, that is sign is different but value will be same. So you are required to find T. So if I take formula of S, S is equal to UT plus half AT square. Initially at rest, both are at rest, means this will go, Q will be 0. So S is equal to half A is QE by M into T square. Now here if you observe all the variables, so if you observe, so S is same constant, Q is the same constant, E is the same constant, only variables are T and M. So M I will take to the LHS, so I can say M is directly proportional to T square, or you can say T square is directly proportional to M. So he has asked us the ratio, that is T2 by T1 can be written as root of M2 by M1. Root of M2 by M1. That is equal to root of time T2 is for proton and its mass is Mp. So numerator you will have Mp, denominator you will have Me. So root of Mp by Me. So option B is our answer. B is our answer. Clear, students? Hope it is helpful to you. Please do share with your friends.